Fine. We've talked about premises, and we've talked about level 1 protection for contamination, level 2 protection for contamination, and level 3 protection for contamination. And we talked about subdividing the space and form follows function, uniflow of process. All these that I have discussed is not something new for you. You have seen it again and again in any number of facilities that you have visited or are familiar with. Now, you notice in the very first slide I mentioned that the regulator, from his point of view, has mentioned 2 areas of concern: contamination and mix-ups. And he said, please design your facility and operate your facility in such a way as to minimize the risk of contamination, cross-contamination or mix-ups. Surely, the way you design your facility and subdivide your space can contribute immensely in reducing chances of mix-ups. But mix-ups are not mistakes made by the building. Mistakes are made by human beings in the building. They are human errors. And that is not the only kind of human error. There is one more kind of human error that nobody has ever talked about while discussing design, operation, maintenance of premises. What is that? That is called goof-ups. That's also a human error. Not doing something you're supposed to do, or doing something you're not supposed to do. Now I'll give you an example of, even if you take all the care you like, you have 2 materials, glycerol monostearate and glycerol distearate. You need monostearate in certain processes and you need distearate in other processes. You buy both from the same manufacturer, supplier, and both of them are white amorphous powders. On a particular day, you ordered 40 drums, 20 distearates, 20 monostearates. They were all delivered in the same truck in the same day. They were then sampled and QC approved it. And you have made very clear that distearate will be on the blue shelf and monostearate will be on the pink shelf. But when it came down and the labels had to be put after release from QC, the labels were put on the wrong drums. This actually happened in one facility. Once the labels were in place, the distearates, or the one bearing the label distearate, were kept on the blue shelves, and the one with the monostearate were kept on the pink shelves. And yet, batches started failing. And failure investigation revealed that there had been a mix-up in the labeling of the outer labeling of the drums. So, mix-ups, if it has to happen, will happen. Human errors, if they have to happen, will happen. Now, you tell me, if a human error is to be avoided, what would you do? You would supervise. If there was a responsible, knowledgeable, committed supervisor, such mistakes will never take place. You have cartons bearing external labels. One set of cartons to go to Bombay, one set of cartons to go to Brazil. And the person issuing those labels doesn't come out to see that the labels are pasted properly. He just tells perhaps a contract worker to go and label. That fellow goes and labels. The entire consignment that has to go to Bombay goes to Brazil. Entire consignment that has to go to Brazil goes to Bombay. And then you have issues at hand, mix-ups. So goof-ups and mix-ups, if they are to be minimized, then you need effective supervision. Now, nowhere else in any other industry do you have layouts the way it is at present in the pharmaceutical industry. Rooms within rooms within rooms, where it may serve one purpose, but it hinders another important purpose, and that is effective supervision. Now I'll tell you what a good supervisor can do. If you were to watch any of the other industries, you will find the shop floor foreman is usually perched at the top in a glass cabin where he can see 500 meters to the left and 500 meters to the right. Why do they do that? It's because they believe in the power of supervision. Now, if you were to have ever attended a Western classical orchestra performance, you will see one conductor and he is coordinating 300 pieces of instruments. Now you see he looks down, he looks at the score sheet, he looks anywhere, he seldom looks at individual performance. Now if you were to attend any of their rehearsals, you will find something. While they are rehearsing, he is looking down and suddenly says stop, and then he says the third person on the fourth row, please play that piece again, and he has spotted, his ears have spotted. Not just that there was somebody going out of sync, but who that person was. If you were to watch a film being shot where there is a dance sequence being picturized and you have a director sitting and there are 60 dancers doing a group dance and he watches them and he says, whatever, camera, light, action. And suddenly says, cut. And he says, the fourth person on the third row. Yes, now you do that movement again. And then he has spotted it. He has spotted one single flawed movement which was not in sync with the rest of the group. This is the power of a supervisor. Now, your supervisor cannot be in 10 different places doing 10 different things. But if you were to stop designing layouts yourselves, reviewing layouts yourselves, and approving layouts yourself, and then handing it over to an architect to say, now build this, which is the custom right now in the pharmaceutical industry. The architect's core skill is subdivision of spaces. Now your job is to tell him exactly what you want, and then he will apply his mind and expertise to help you place your supervisor in one place, and from there he can supervise 10 different activities in 10 different places. That's the specialty of an architect. Now, your job, according to ISPE, they suggested that you look at your process from start to finish and mark all those places which are low level risks or no risk at all. Product is not exposed either to environment or to the operator, so it is a level 1 environment, and it is a yellow level risk. Then product is briefly exposed either to environment or to operator or to both, but briefly, for a very brief period. It's moderately at risk. So he said, you paint them orange. They require level 2 protection. Then he said, look at all those places where the product is at high risk to contamination, either from the environment or from the operators. Mark them all red. They require level 3. He called one a general area, then he called one a protected area, then he called one a critical or controlled area. You do the same thing vis-a-vis the human beings. Start from the beginning of your process to the end of your process. Find out where the process is at risk from either a goof up or a mix up. First look at the goof ups, where people can make mistakes, and then look at it from the mix ups point of view. Where there is no interaction between operator and the process, they are all yellow areas. Mark them yellow. Where there is a brief interaction between an operator and the process, and there could be a chance of either a goof up or a mix up, then mark them orange. And where there is high possibility of goof up or mix up, like your packing and labeling area, your weighing and charging area, mark them red. Now, you give this to your architect and tell him that in the yellow areas, if there is no supervision, it's not critical. But in the orange areas and certainly in the red areas, I need supervision. Now, how do you supervise? What does the supervisor do? The supervisor sees. So first he has to be able to see. If he is able to see, then he will be able to observe. If he is able to observe, then he will be able to monitor. If he is able to monitor, then he can identify a situation and necessarily intervene to take either a corrective action or a preventative action. Therefore, he can have control. So, to observe, monitor, intervene and control, a supervisor must first be able to see. I am now talking about a patent that has been filed by a gentleman in Singapore, and this is way back in June 14th, 2002. Now, what does he suggest? This patent is downloadable from the net, and I request all of you to read it. Now, what is he suggesting? He is suggesting dramatically different layouts, where there is a supervisor at the hub and all activities are along segments which form the spokes. And the process can move from one room to one segment to the next segment to the next segment. And he is still in a position to keep track of what is happening. Being in one place, he can see activities in several rooms. Now, he has shown it in a polygon form, he's shown it as a circular form, he's also shown it as a rectangular form, where he shows people entering in one direction, walking into a particular space, and then exiting through another direction. One entry for men, one entry for women, with separate change rooms and separate exits. And the operators are all under supervision from a man sitting right in the center, where he has a view of all that is happening around him. This is the kind of layout that can take pharmaceutical manufacturing to the next level, if you can empower your supervisor and proper supervision. Closed circuit TVs are not going to help you. Nobody has the patience unless even if you have several people sitting and watching the screen when people use such surveillance. So if you have one man and he is an expert in his job and committed to his job, be sure about it. The number of human errors committed on your shop floor will come down dramatically. But for that, you must empower your supervisor by giving him a design, a layout, a subdivision of space in such a way that he can be in one place and effectively supervise. Let's first understand, most people select a site, appoint a project manager, and he happily goes about doing his job. Nobody is kept in the loop, and then suddenly you find that the ribbon is cut, everything is arrived, and then the production people go there, and the quality assurance group go there, the quality control people go there, and they find that there's a total mess over here, that equipment intended to be kept in a particular place doesn't fit into that particular place, the utilities are in the wrong place, the power supply is in the wrong place, the switches are in the wrong place. Ever so many things happen. Why? Is because nobody ever asked the end user his view on how a facility ought to be. It is just given to that person, and you waste a lot of your time in trying to qualify your equipment and get your process started. You are supposed to be having a validation master plan. Invariably, everybody has a validation master plan, but that is all written 2 weeks before an inspector is arriving. A validation master plan is supposed to be a roadmap for that project. And a validation master plan will require that you reference all the protocols, whether it is a validation process validation protocol or an equipment qualification protocol. Now, their important protocol is the design qualification. And today you have one more step involved, and that is the subject matter expert's verification. One subject matter expert who works with that project, and another subject matter expert quite independently sits and reviews the verification carried out by the first subject matter expert. That is today's requirement. Now, if you were to have your design qualification process where you bring in everybody who's a stakeholder to the table at the time when you're discussing the design, before you finalize or firm up the design, before you hand it over to a contractor. If you were to have people from production, people from maintenance who are going to maintain that equipment, they will bring in a pool of suggestions to make sure that the premises that you design are indeed fit for use.